So we have done the analytical characters, which were composed of qualitative and quantitative characters. So you remember, right? Quality that we cannot measure and quantitative that we can measure, like frequency, density, etc. Then, other than the analytical characters, there are other characters known as synthetic characters. Okay, synthetic characters are those which are very complicated in calculation, that sometimes you will need statistical tools, you will need Excel sheets, you will need computers to perform the calculations. Okay, so what I mean is, if you want to get the overall idea of the community, you will have to take many characters into consideration. Like for example, importance value index that is there in your practicals. Other than the frequency, density, abundance, we would be doing separate practicals, right? For frequency, separate; for abundance, separately; for density, etc. But for importance value index, we take into account all these quantitative characters. We will study in IVI, when we do importance value index, we'll study density also, frequency also, basal area also, and other characters. So the numbers, we know the number, we know how dense, we know how abundant it is. And then we have to use statistical tools. We'll be using statistics to understand the overall idea of the community. Okay, is it a rich or is it a sparse? So this is just your general introduction about synthetic characters, where we use computers and hire statistical analysis to get an overall idea. Okay, so not just the frequency, not just the density, not just the abundance, we'll be calculating all of these characters together, clumped together. So let me read out. Synthetic characters, they are determined after computing data on the quantitative and qualitative characters of the community. Okay, so not only are we doing the quantitative, we are doing also the qualitative. I think that's better, bigger. Okay, so here you have wait, let me underline again. Here I think you have understood what I have explained, because means when we are doing synthetic characters, we want the whole picture, whole idea, not just the quantity but the quantity also. So we will be computing the data on both the qualitative and quantitative characters of that community, whether it's a grassland community, forest community, desert community. You have to take everything into consideration. Okay, so for comparing the vegetation of different areas, community comparison needs the calculation of their synthetic characters. Okay, so if you want to figure out the vegetation of different places like desert ecosystem, like forests or ocean, etc., we have to compare the community, and then we have to compare these different characters, whether qualitative or quantitative, by using calculations. Okay, different formulas will be used. So let's look at some of the different types of synthetic calculating method. Okay, the first one is presence and constants. Okay, presence and constants. Okay, so this one, it expresses the extent of occurrence of the individual of a particular species in a community. When we say extent of occurrence, means how much it occurs. Is it uniformly distributed? Is it sparsely distributed? Is it only present only sometimes? Let's say we are talking about the class. Okay, like in the classroom, you have zoology honors, botany honors, and chemistry honors. So if you look at botany honors, the girls who attend the botany class will be many, lots. So they are mostly present or constantly present. Then zoology also, they have, because it's compulsory for them. So they are also mostly present. But what about chemistry? chemistry, they could either take zoo or bot or C and D. No, so they are open. No, so they are very rare. Okay, few girls only, maybe 10 or 11 girls will be taking chemistry. So those are seldom present. Okay, so it gives us the extent of occurrence of the individual. Okay, extent of occurrence, that is how uniformly a species occurs in a number of stands of the same type of community. The species, on the basis of its percentage frequency, may belong to any of the five present classes that were first proposed by Braun and Blanquet. So this class was given by Braun and Blanquet. It's similar. Remember, around here we had class A, class B, class C, or D and E. No, he says this much percent, maybe 20%, they belong to class A. If they are 50%, they belong to class C, etc. and so on. No, so this is also similarly. So if that species is present only in around 1 to 20% of the sampling unit, let's say this is the sample unit. No, in this quadrant, let's say strawberry only 1 or only 2. So out of this entire, so doesn't it hold only barely maybe 5% of the entire community representation? So it means that it is rare. Okay. Then it is seldom present if it is in between the percentage of 21 to 40%. So let's say in this quadrant, in this quadrant, we found this much only strawberry. Then around maybe this much, these two, around 20 to 40%, we are finding oxalis. So they will say that oxalis is seldom. Okay, it's not rare, but it's seldom present. Then it's often present if it occurs in between 41 to 60%. Okay, so let's say this much, 41 to 60%. So if it's there, we'll say it's often present. Let's say for trifolium. Then mostly present or constantly present means 61 to 80% or 80 to 100% will be for grass. Grass too you'll have everywhere, no? So you will say that constantly present in grassland community is obviously grass. So I think you have understood presence and constants. Okay, means how uniformly it appears. Okay, then the next one, it's the fidelity. Can I move this? This. Okay, leave it. Okay, fidelity means it is the faithfulness. Okay, fidelity or faithfulness is the degree in which a species is restricted in distribution to one kind of community. Okay, the key word is faithfulness here and restricted. Okay, so means it has to be faithful to where it is from the community. Like for example, in Meghalaya you have let's say 3 tribes. No, this is the state of Meghalaya. This is Jaintia Hills, this is Khasi Hills, and this is Garo Hills. So how faithful is the Jaintias in their place? Obviously you will find them. So this is in that community, they will be present. Okay, the Jaintias. Then the Garos will be present, will be faithfully present in their own place, in their own community. Similarly like that. So sometimes, let's say you got kidnapped, and then you after one day's journey, your blindfold was removed and you saw full of Garo people. Then you will know that you have been kidnapped and you were kept in Garo Hills. What if you were kidnapped and you met a lot of Khasi people? Then you will know you must be in Khasi Hills, right? So because of the presence of those people, you knew you are in that place. Or let's say you got kidnapped and you were in a place full of Japanese people. You know you are in Japan. Okay. So such species will be known as your indicators. Okay, means say just by looking at that species, you know where you belong. For example, here in Shillong, we are finding in the hills, we find lots of pine trees. No, lots of pine trees. Okay, These are the hills, lots of pine trees. So just by looking at this pine, you know that if it's Pinus, if it's Pinus cassiana, I cannot write, okay, with this, my fingers are difficult. If it's Pinus cassiana, you know that you are in Khasi Hills and the indicator species is the pine tree. Okay. Similarly, with the other endemic plants such as Nepenthes cassiana, you will know that you are in Meghalaya, no, because it's endemic only to our state. Okay, that also only to Garo Hill and Jaintia Hills. All right. So such species, because they are faithful to their place, they like to stay only in that place, in that community which is suitable for them, so we can use them as indicators. Okay, so now how do we use these indicators? How do we use this faithful species to calculate the synthetic characters? So the species have been grouped into 5 fidelity classes which were first formulated by Braun-Blanquet. Okay, so same scientist who gave us the constants, presence and constants. What was that? Yes, presence and constants. Okay, the same scientist, he gave us about the fidelity. So he says that fidelity 1, okay, or strangers will be that plants that appear accidentally. Like for example, in that grassland community, I said that there was one strawberry. Okay, and obviously, isn't that accidental? Maybe somebody ate a seed of strawberry seed and it's just suddenly appeared. One strawberry plant appeared. Suddenly it appeared. It doesn't mean that in this grassland community strawberries are there. No, wrong. So these are stranger plants, means by mistake somebody ate a strawberry seed. This girl, she ate the strawberry. Then one seed fell in the grassland and it grew. Somehow it grew by chance. But it doesn't mean that it belongs here. It just so happened. Okay. So fidelity 1 are those that appear accidentally. Now fidelity 2 or indifferent. Okay. It's like hi-bye friends. No? Like you have a best friend, like like I have Miss Dihon, like best friend. No, hi Miss Dihon, where are you coming from? What about what if I meet a teacher from like I don't know very well, who will it be? Okay, what if I meet a teacher from St. Edmunds? Okay, I would be indifferent. No, I don't know them, they don't know me. So it is that those are the indifferent plants and they may occur. Okay, these are also, they are there, but they are not really like very much very much popular in that community. Now fidelity 3 are the preferentials, those who occur in several kinds of community but are the predominant in one. Okay, so these are the species, they can live anywhere. Okay, just like Eupatorium, it can live anywhere. No, it can live all over the country. There are different kinds of Eupatorium, no, like in India. No, oh my god, the map is so bad. Yeah, fine. Eupatorium, it first appeared in our place, okay, in the northeast, but there are other Eupatorium in, let's say, J&K. There are different kinds of Eupatorium species in maybe the Malabar coast. Okay, so they appear in several communities, but they would prefer to be in one. Okay, but they will be predominant in our place. Okay, because we are in the northeast. No, they're in the hotspot. We have many good plants. So fidelity 5 are the selectives. They are present, selective, no, means they are very selective where they live. They are present in one community but occasionally occur in other communities as well. So it will be like your Sora, Cherrapunji, what fruit is that? Cherrapunji orange. Okay, it prefers to be in Cherra, obviously. But if you grow it nicely here and there, let's say in the greenhouse, it might grow well in other places also. I don't know. It might grow well. I think yes. So they prefer to be in Cherrapunji only, no? But occasionally, if you give enough effort, then they can grow in other communities as well. Then let's look at the fidelity number 5. These are your exclusives. Okay, exclusive. Just like the one-horn rhino. Then you have your Nepenthes cassiana. They cannot survive anywhere else. Okay, one-horn rhino, it cannot survive anywhere else. You know, it can only survive in Kaziranga, right? And this Nepenthes cassiana, it can only survive in its park, no, where it's protected. Mauplang, what is that? Sacred Grove, no? It's present in only some places. So they cannot survive anywhere else, okay? And they are very rare, and also not only that, they cannot survive anywhere else. They can survive only in that particular community which they are adapted to. Okay, so the next one is dominance. This word keeps appearing, no? So dominance, it can be used as a synthetic character as well as an analytical character, because dominance, we calculated, is it in the quantitative as well as qualitative characters, no? But dominance is very flexible, no? We can use it for analysis also, and synthetic also. So if we look at the synthetic point of view, dominance will mean the number of organisms sometimes may not give a correct idea of the species. Okay, just because suddenly you saw so many butterflies doesn't mean that butterflies survive throughout the year in that place. It just could be that at that particular season, maybe it is a butterfly evolving season, you know, when they are molting. Okay, it doesn't exactly mean that it gives you the exactly same idea just because the number is more, because it depends on season, depends on temperature, you know, depends on many other environmental factors, right? Okay, so on this basis, the scientist Dobbenmeier, if one bases his conclusion on the number, a single or a few trees in a grassland or few grasses in a forest should be of little value. Okay, so if you base on the number, okay, just because you saw a few trees doesn't mean that it is a forest. No, it's still a grassland. But just because you saw some grass in one forest doesn't mean it's a grassland. It still means it is a forest. Okay. So one should also consider the species on the basis of area occupied or biomass. Let's say if this is the grassland community, there is one patch of trees here. Okay. Okay. So if you total all these grasses, okay, you collect all the grass from here, from all of here, and you weigh it in a scale, no? Wouldn't the grasses become heavier? Wouldn't the grass become heavier than the trees, because there are few trees only? Okay, so you understand, when we say biomass, we're talking about the weight or area occupied. Okay, so here there were few trees. Okay, here one patch of trees here, one patch of trees here. Now if you look at the area here and here, I'm taking even the cover area. Okay, if you look at the area here and here as compared to the area here and here and here and here, you will realize that grass still is more dominant here. Okay, so just because there are few grasses or few trees doesn't mean that we can assume that is a grassland or a forest. Okay, we have to weigh it, we have to find the area occupied. Okay, therefore cover is included as an important character in dominance. Okay, so let's look at the how to calculate relative dominance. This is not lover, it's cover. It's cover. Okay, relative dominance cover is equal to dominance cover of the species divided by dominance cover of all the species into 100. Means, let's say if this is tree, okay, this will be tree plus grass plus herbs plus shrubs Okay, so 3 divided by herb, shrub, blah blah blah. Okay, then if you find that tree is just 1%, you know that it must be another community. Then if you divide, let's say shrub, divide into 100, because it's relative dominance, you have to do 3 plus, I'll just short, okay, shrub plus grass plus herb. Then let's say shrub, you got 30%. Then when you did with grass, okay, relative dominance of grass, you got grass, so 3 plus grass plus shrub plus herb into 100, and you got, let's say, 80%, or how much, 78%. Okay, so you will know that this has to be a grassland community. Okay, let me go on to the importance value index. Now this one is there in your practicals. So this index is used to determine the overall importance of each species in a community. Okay, so let me show you. For example, this is a table. Okay, we have made one table. Okay, here let's say is trifolium, here it is oxalis. Okay, so you found the frequency of trifolium is 70%, of oxalis is 40%. Then you found the density was 50%, here 20%. Then you found the abundance was 20, 12. Then what else? Basal area you found. I want to draw a better one. I want a blank place. Okay, here I think will be better. Okay, let's say I am trying to draw a importance value index. Okay. I'll show just one example. Trifolium. Okay, the frequency I found it to be 30. Then density was 40, abundance was 50, and then basal area was, let's say, 60. Then you total all these, the sum of all these will give you the importance value index. Okay, let's say roughly this will be equal to 6 whatever. Let's say roughly this is like 120%. Okay, oh my goodness, what happened? Okay, then you found oxalis, so then you found it as, let's say, 90 or 80%. So then you will realize that the most important species in that community, you found that the most important species in that community is your trifolium. So it gives you an idea of the overall importance of the species. Okay, because think about it, if we are taking into consideration one thick, unless we get to do the practicals, it will not be clear. Okay, so I think you have understood roughly. So let me go again. I'll go line by line easily. So this index is used to determine the overall importance of each species in a community. Okay, in calculating this index, the percentage value of the relative frequency, relative density, and relative dominance are summed up together. So we have totaled it together, and this value is designated as importance value index, IVI. Okay, importance value index or IVI. So it gives us the idea of the sociological structure of a species in its totality in the community. Means how important it is in total. Okay, let's say there is one girl. She is tall, she is fair, she is beautiful. Okay, so she has all these great characters, but she's stupid. Okay, I know you'll be laughing. She's stupid. So her stupidity brought down her importance value index. Then let's say a girl, she is medium height, she is cute, she is also fair, and she is not just intelligent but she is brilliant. So this has brought up her importance value index. Okay, so I think now you must be understanding, no? If we are talking about girl, we are talking about her overall looks, everything, looks, brain. So here she has the looks, then she has, let's say, the cash, the money. No, she's very rich, then she's very brilliant. Okay, then she's got style, she's stylish. So this is girl 1, she has all these. Okay, so she has an importance value index of 100%. Then girl 2, she has the looks, the money, the brains, and the style is not there, so maybe 50%. Okay, then girl 3, she has only money and she has only money, nothing else. So her importance value has gone down, it gone maybe only 20%. Okay, so I think you understand now, no girls? You have to take all those grasses in the grassland community and find their sum total, and you have to compare who has the best importance value index. Okay, excuse me, because in a grassland community you will find trifolium, you will find oxalis, you will find plantago, then you will find hypogaea, then you will find what is that, lyco something, then you will find other. Okay, then you have to compare this one, how density it is, what's the density, what's the abundance, what's the basal area, etc. This one also, all density, abundance, frequency, basal area, everything. Also frequency. So you have to find this for this also, for this also, for this also, the others, and then you compare who has the overall best importance out of them. Okay, let me continue and I read again. So it provides the idea of the sociological structure of a species in its totality in the community. Okay, so in total, but it does not indicate its position separately with regard to other aspects. Okay. For importance value, values of relative density, frequency, and dominance are obtained as follows. Okay, we have to talk in the terms of relative. Okay, means we have to multiply by 100. Okay, we have to calculate in terms of the percentage. When we say relative speed, means in terms of the percentage. Okay. So relative density, relative frequency, relative dominance, these are the formulas. Simply, relative density will be density by total density into 100. Okay. Then if it's relative frequency, it will be frequency over total frequency into 100. Then if it's relative abundance, dominance, it will be dominance dom over total dom into 100. It's basically the same formula. Okay, same formula. See, you just replace this with this with this with this, total. Okay, then if it's relative density by total density into 100, then relative frequency is frequency by total frequency into 100. Dominance also dominant by total dominant into 100. So easy. Okay, so other synthetic characters. So besides the ones that were mentioned above, there have been proposed some other characters which have been quite useful for comparative studies. Okay, such characters include interspecific association and association index, index of similarity, dominance index, diversity index, etc. These are all computer programs. Okay, we use them in the programming. So with this, community as a complete unit is done, but another unit is still left, the population unit. It's quite a long chapter. So population also I have to start.